going to be another long video as well. So, 4.075. So every time you do an overclock, you always want to check that it's set properly, because like we had that issue earlier where the voltage wasn't correct, and obviously it made us crash. Well, if you open CPU-Z before every run, then you can check these things. And when it goes all wrong, you know it's gone wrong. So at this point I'm kind of expecting it to crash. Maybe not on this run, but on one of these runs. It's pulling about 380 watts on that run. So you can see the score's gone down quite a lot from the last run. I think it's getting near to the limit now. Don't think it'll run at all at 4.1, to be honest. No, it's still learning, it's still going up. Still 40 points off where it was before. But then we did only go up 25 megahertz, so... Yep, 360. It's getting there. We'll go real time. See how it does there. Might crash on the first attempt, you never know. It's that killer network driver from a gigabyte board that I installed. Kills all your performance. Not good. Should probably uninstall that, to be fair. So we'll run it a few times. Interestingly enough, on the last runs it was getting to 398 peak. And it's actually using slightly less power. It's only got to 391 on those 3 runs. So I might just run it one last time. Probably crash on this one, which is annoying, but whatever. Always reboot. Yep, still 391.8 watts peak there that I saw. So, a bit weird. And it's done. So, we shall have a look. And it's a lower score. That is very interesting. So it is a lower score, so more power usage means higher scores. How strange is that? Even though it's faster, it's scoring lower. Must not be as stable. Or something must have changed somewhere. I ain't changed anything, obviously. Apart from the speed. Put the speed up. And the CPU's still at the correct speed that I thought it was. Let's just check. 4.07. Indeed it is. Maybe if we reopen it again. Maybe it's just got stuck getting the same score over and over again. Okay, it just needed reopening. Dunno. Let's try it one more time in real time. One last chance. Then we'll try 4.1. I'm gonna guess it's gonna crash at 4.1. It's already getting slightly slower. So you'd be better off leaving this at 4.05, clearly, because it was really happy at that. $395 watts that time. And indeed it has scored a little higher, look at that. How weird is that, but only 25 megahertz. So we're going to run it again, so we want 3400. Nope, not having it. 3396 is where she's at right now. That is hardly an improvement on the last score. Hardly. I think it's 4 points more on a 16 thread CPU. or 16 core 32 thread CPU, sorry, which is not very much. For some reason that 4.05 GHz was very, very fast. I was surprised on the jump on the previous score, to be fair. So I'm not entirely sure how we managed that. But it did. It got the score. It was valid. It rendered all the tiles. Oh well. Whatever, we've beaten it anyway. Only very slightly. I don't particularly like editing. Oh well. 4.1 GHz it is. So let's check the megahertz in the CPU Zs. Should be 4.1, and indeed there it is, 4.1 GHz, 1.4 volts. If it worked at this and got a decent score in Cinebench, obviously, that would be pretty damn spectacular. The fact that it's even booted up is pretty impressive, to be honest. I'm not expecting it to run this at all. Still limited to about 380 watts by the voltage, I presume. But it is looking to score a bit higher than before, I have to say. Doing alright. Surprised it's even running like at all. This is pretty crazy, really. I mean, look, the score's even going up each time as well. 392 watts. Maybe if I gave it a bit of load line calibration with 1.4 volts, it'd, oh there we go, 3,401. I think with a bit of load line calibration, it'd probably boost the voltage quite a bit higher when it was under load, which would obviously help the come on brain, the CPU draw a little bit more power by giving it a little bit more voltage, a little bit more current when it was under load, and then when it went back to idle again, go back down. So it's just trying to even out the peaks, but you don't have any peaks, so your peak voltage would be higher, but then your non-peak voltage would be the same still. So it would be nice to keep it like that, but we will see anyhow. Can it run it in real time? That is the question. Can't believe we haven't seen a blue screen yet. It's a pretty amazing CPU, to be honest. And the power management on Ryzen's clearly very good as well. You can clock it way too high for the voltage, and it still runs, which is kind of weird, because Intel CPUs will just blue screen. They'll boot into Windows, maybe post, but yeah, they'll definitely blue screen. And the VRM heatsink is stone cold as well, with that nice cool airflow over it. Really, really cold. It's excellent. It's genuinely cold, even when the benchmark's running, which it is. It's just finished. Stone cold. Brilliant. That VRM heatsink has got a lot of surface area though, so props to MSI for making an actual decent VRM heatsink. Although I haven't tried it passive, it's probably melting and the aluminium's all dripping off when it's passive, but I've got a fan doing 2000 RPM pointing at it, to be fair. But, there we go, look. 2405. So I feel like we're being bottlenecked by either voltage or the memory, because the score is going up, but it's going up like a tiny little bit each time. And you saw when we went from 4.0 to like 4.05, I mean we gained nearly 60 points, 50 points in just 50 megahertz, and we've gone up another 50 megahertz and we've hardly gained 10 points. So what is going on here? Well, the voltage has been the same for those 3 steps we've just done. So I think the Ryzen power management is allowing it to run at 4.1, but the CPU's not running at like peak performance all of the time, even though you wouldn't notice it or see it in any software. It seems the CPU has got some kind of internal power management which says, look, we try to run at 4.1 as much as we can, but we can only put so much work through the CPU. Or we're being memory bottlenecked. So the easiest way to test that is to increase the memory speed, obviously. So we shall give that a go, I think. So we're going to try 3600, but we're going to need a bit more SoC voltage, so we're going to put it on the one under 1.2 volts, and we're also going to up the RAM voltage to 1.5 as well, and it's gone red, but it should be okay because it's B-die, and B-die likes having 2 volts put through it, and even though this stick is dead, it's never had 2 volts put through it while I've owned it anyway. So yeah, the highest it's been is probably 1.7 volts, which isn't particularly much. Now if I can show you the post thingamajig, oh, you can't see it because the water tube's in the way. You'll be able to see that it is not posting. Computer says no. Oh, it's trying. It's definitely trying. But not quite hard enough. So it might look like 3600 is a no-go. Because it doesn't look like it's going to post. It's almost there, but not quite. So we'll shut it off. I'll get it to a point where it's posting again, and then we'll try something new. So this is a really good sign for this board. I just went to get a drink and left it on, not posting, and the board's actually sorted itself out and booted into Windows. And what the board has decided the best course of action was, is to, let me just get the camera straight here because it's actually annoying me. That's not straight, but whatever. It's just decided to put the memory back to 2133, which is a very safe setting, because obviously it probably tried XMP as well, which is 4000 MHz on this kit, so it probably wouldn't have been able to do that. I'm trying to get the camera to focus well here, there we go. So 3600 did not go very well at all. But what we're going to do is we're going to boot at 3600 first, or not 3600, 3466. So it's not reset all your settings, so it's not reset your CPU and all that. It is just reset the RAM. So all I'm doing is putting the RAM back to where it was before we make any more changes, because RAM training is a thing. So hopefully it'll actually boot up. So the next step, now that we know we can't go a higher speed, we're actually going to go to a lower speed. So we're going to go to 3333. But instead of using the same timings, what we're actually going to do is we're going to try 13, 12, 12, 12, 12. And we're just going to boot at that. Still at the same settings as before. So we've still got our SoC voltage a bit higher. We've still got the RAM voltage a bit higher at 1.5. But we're just going down a step on the memory. So we'll see if it can boot this. D1. I'm going to guess that means no. We'll reset it. D1 again. Now the problem is the RAM stick is all the way out there. Ideally we'd want it to be in the centre. Not that it would make much difference because this is a 4DIMM board, so all the traces have to be the same length. But at least it wouldn't have to go past all of the other DIMM slots, the signal with all those little pins on the back, just to get to the CPU. That is not in focus. We're getting a D1 every single time. So it looks like this isn't going to work. So we're going to have to try something else. Right then, we've finally managed to get back in to where we were, which was 3466 again, and 14, 13, 13, 28, 68, 320. So, now last time I only raised this channel's voltage to 1.5 volts and not the other one. So, oh, and it actually only allows us to go up to a maximum of 1.5 volts, that's interesting. So, I guess that's the max we can go to. So anyway, what we're going to try this time is, because 33 didn't work, and 3600 didn't work, so what about 3200? But this time we're going to go down C12, 11, 11, and then maybe 300 on the TRFC. So we're going to try this. See if that works. Seems to be posting so far. Maybe I spoke too soon. No. We have a screen. Almost have a screen. There we go. Will it get into Windows? That is the next test. Let's have a look in CPU-Z and see if our settings have applied correctly. So this is C12. So 12, 11, 11, 28, 68, 300. So our settings have indeed worked. So we can try run again. See what kind of a ballpark figure we get. Oops, he needs to zoom me out there. Still pulling 380 to 390 watts. $398 watts there, quite impressive. Probably because I put the SoC voltage up, to be honest, rather than the CPU using more voltage. We'll give it a quick couple of runs on real time. I don't think we're going to beat our previous score, because I think the extra memory frequency in this case will help more than the tighter memory timings, purely because we're running single channel. If we were running dual channel, this could potentially be faster, or quad channel even. And there we go, 3,374. So indeed, the memory speed was helping us more than the timings, which is understandable. Okay. So what we'll do now is, I think we'll try these same timings, but on 3333. And you may think, well, we tried 3333 before at 14, 13, 13, or was it 13, 12, 12, and we're now at 12, 11, 11. This is never ever going to work. But I think because we've run it at 3200 first, you never know, it might actually run at 3333, even though we're on tighter timings. So let's have a look at the postcode here. 54, 33, 55, 36, 62, 06. Is it going to try again? Or is it stuck? Could be stuck again. Does look kind of stuck. It's a very black screen. And this is a very stuck on 06. Come on board. You can do it. You can do it. Maybe you can't do it. That's disappointing. It's kind of hoping that would work. So we can get into the BIOS and you can see we're at 3333. We'll give her one last go. It's not quite got it. I don't think it likes the 33 memory multiplier. Here we go. The screen is on. And there we go in the BIOS. But you can see it's reset the RAM to 2133. Top there. So it did sort itself out, but it did take its sweet time there. But it did a pretty good job, to be honest. I was quite impressed. I mean, it took ages, but it never just sat there for like 20 minutes. Like some boards would literally just sit there forever and let you stare at them like an idiot. So we'll go back to where we were, because we were comfortable at that. Now all I'm going to do is raise the voltage on the CPU. I'm not going to go up too much, just 4.25, that is all. And we shall see if that makes a difference to the score. Now obviously if the memory was bottlenecking it, we won't get a higher score when we've added more voltage. And if the voltage was bottlenecking it, we'll get a higher score now. So we've tested one thing and we know we can't get the memory to go any faster, pretty much no matter what we do. Now the first thing I'd like to see improved on that memory is maybe after like 5 times trying to restart, it could stop trying to restart and go back to where it was before. I think that might actually be a feature in the BIOS, but I don't have it turned on. Now the other thing I would like to see maybe MSI implement on their Ryzen boards, I don't know whether they have this on the higher end Ryzen boards, but the memory voltage only allowed me to go up to 1.5 volts, which is fine for daily usage, because you don't want to go any further than 1.5 volts for daily usage. But for extreme overclocking and benchmarking, which MSI don't actually support anymore, which is probably why this is the case, 1.5 volts is pretty useless. I want to be able to put 2 volts through my B die. If needed. Obviously I didn't really need it on this platform, but maybe 1.6 volts, maybe 1.65 would have helped. I think 1.7 or 8 would be a nice limit. I think the Asus X370 Prime Pro, which I use for AM4, the voltage limit on that's 1.8 volts. So yeah, I think that's a good limit, to be honest. On an overclocking board like the Hero, you want the full 2.2 volts limit, but on a board like this, I think 1.8 is reasonable, to be honest. Anyway, we have raised the voltage up, not down. Let's get the right resolution. I don't know why I keep particularly picking this one. But all we've done is raise the voltage. We have not raised the speed at all. So you can see there 1.432, so it's putting a little bit of load line calibration in there. It might come down in V-droop once we put it under load. But it's still 4.1 GHz, memory's still the same speed. I'm starting to lose my voice as well, which is nice. So let's zoom out. Okay. So, if we watch the voltage here, if I can get them both to be on the same screen on the phone, I'll probably zoom in a little. So you can see the voltage in the top corner there. So let's see how much it V-droops under load, if it does at all. So there we go, 1.424. That is a sign of a well sorted BIOS, that the V-droop is very low. So yeah, that's pretty nice. Now obviously that might not be entirely accurate because it's software, but that's the best I can do right now because I'm not going to hook up a multimeter. So that's good enough for me. That is saying that this board is actually putting as much voltage as I told it to through the CPU, and not a huge amount more with loads of LLC, and not a huge amount less. And to be fair, I've seen a lot of MSI board reviews online recently where on the auto settings the MSI board has been absolutely rinsing the voltage through the CPU, and it's not good. But it's good to see that the load lag calibration at least is sorted pretty good. So yeah, it couldn't really get much better. It's running a 16 core, so if it can keep this 16 core in check, if you have an 8 core or a 12 core, it's clearly going to keep that in check as well. So the MSI board for a sort of gamer oriented board is doing pretty good, to be honest. I don't really expect too much more of this kind of board. So anyway, let's see how much power she's using, shall we? So before I start the test, I'm actually going to find the torch and show you the power meter again. So hopefully you'll be able to see over 400 watts now. So if its own cable doesn't get in the way, run the selected tests, and off she goes. There we go, 400 watts. So more watts equals more score, right? So we've got 3,405 to beat, I think it is, and that's finished. So we'll go again, twice more. So I think it peaked about 412 volts, not 412 volts, 414 watts that time anyway. So this is CPU only load, obviously. But from the wall, not actual CPU load. So it's probably pulling about 360-ish in actual voltage going through, or wattage going through the CPU and into the water loop. So there again. We'll go one more time, why not? It's so fast, it's unbelievable. Go one more time. Hopefully it doesn't crash. Although I doubt it will, because it didn't crash before when we were using less voltage, so yeah. So there we go. That is the last time. So I'll put you back on the tripod and see what score we've got. Boom! There we go. 3,423. So, same speed, different voltage, higher score. Very interesting. So we gained an extra 20, about nearly 20 points there, just purely by changing the voltage. Now, if I went to a higher voltage, there is potential that it might go to an even higher score, even at the same clock speed. So we could try that as well. But actually, what I do want to try is an even higher clock speed, because I don't know, this thing might hit 4.2 gigahertz on this voltage, and that would be insane. Try 4.125. So we should be at 4.125, which we are, still at the same voltage, of course. And we're going to go for it. Whoops, and zoom out, zoom out, zoom out. There we go. Oh, that's terrible. Well, it's not terrible, but not particularly good, is it, really? For the speed that we're at. That was not a very efficient score at all. Yeah. You can see we're getting the same score over and over again. It's not actually improving very much. And I think this has some kind of sort of power limit thing, a bit like the Vega GPUs. Oh, there we go, we got an error. A bit like the Vega GPUs, where you can go faster and faster and faster, and your score can get lower and lower and lower unless you give it some more power limit, basically. Which is, in this case, it's more of a voltage limit than a power limit. So you're not undervolting to gain clock, you're sort of underclocking and not losing any speed. So, I don't know if that makes sense. But that's what I'm seeing here. If I go up to 1.45, which is when it goes red at 4.1, I think it'll score higher. So you can see we're at 1.45 volts. This is probably the final voltage, because I don't want to run it too much at this, because it's probably going to get pretty toasty. It's using 430 watts, approximately. And that scores terrible. Yeah, it's kind of using 420 to 430 watts. So I think at this point it might be thermally limited, even with the amazing XSPC water block and my 1080 radiator. I can only do so much, obviously, with a water block, because you're limited by the block. 3396, that is lower, so we've lost efficiency again now. So that is pretty much it for this one. So obviously 3423 at 1.4 volts, I think it was, or no, it's 4.125 volts was the highest performance, but I think the best efficiency wise was 4.05 gigahertz at 1.4 volts. That seems the sweet spot for this CPU. That'll be it for this. Thanks for watching, and hope you enjoyed it, even though it was a bit long. And I'm going to go and have fun editing this now. Goodbye.